So welcome back, everybody. This is the first of my series. As if you saw the introduction to this series, I talked about this book, Quadrivium, and about general knowledge that over thousands of years has been passed down to us from a lot of so-called esoteric teachings. And once upon a time, if you were a very, very educated person, again, there are people like the famous people like Da Vinci and so on, and all those Renaissance people, standard knowledge was considered geometry, numbers, proportions, music, harmonies. All of these things were considered like high knowledge, because if you want to design, say, a pyramid or a great cathedral or something, all of these principles, just fantastic base of knowledge has come down to us. And this is just one example of many, many, many books about the subject. Here's the one that starts about music, for example, all the frequencies and the different notes and so on. So a lot of the people, we didn't have back then the same kind of measuring instruments that we have now, electronic instruments and so on. So people observed nature, and there's very many examples of incredible genius, people like Da Vinci. They observed nature. They used tangible things, looked at them, and understood the abstract concepts about something, and the colors and everything, and shapes. And they came up with amazing different kinds of sciences or mathematics and so on. And it wasn't unique to the Renaissance. This goes back a long time, because in ancient India and ancient Egypt, they had extraordinary knowledge of the cosmos and the stars and the motion of the earth and so on, and all of these principles that we're going to be talking about. So what I'm going to try to do is just make these very simple segments, and they're sort of randomized because you can't really make a sequence and call it, it's just so vast. And what I hope to do is trigger people's own imagination and understanding, so that you get things on your own. Real knowledge has to be practical for us, and we have to know in ourselves that what we're experiencing and knowing is real knowledge. It's not theory. So how do you do that? Again, back to nature. Just using our senses. We have amazing senses and subtle senses that we can develop in perception through various techniques of meditation, and to expand our perceptions so that we grasp some of these abstract principles. And then you see that we live in a profound universe, and we're just part of it, and it's just fantastic. So I'm going to go through a few basic concepts, and then I'm going to make little drawings and go step by step in a particular sequence here, and try to have some conversation as I draw and make notes to introduce various principles that might trigger something in your own mind, so that you can maybe go off on a whole different tangent and investigate something that attracts you in this vast realm of knowledge. So I've got a few words here. One of the most profound little statements that we've all heard about probably right now is "as above, so below." And it basically was talking about the macrocosm and microcosm. There's self-replication in the cosmos. There's over and over again, you see the same shapes, the same geometry, the same principles, the same things from the top down to the bottom. So what that does is helps us understand. For example, maybe we cannot see electronic waves, but we can see waves in water, and we can see wind spirals and dust spirals and water spirals and star spirals. We can see these things in nature, and then we can start using our intellect, because our brain, this whole subject again of our self-knowledge, our what is our consciousness? We can't really measure it. So whatever we perceive, whatever we understand, whatever we grasp in the deep part of our own meditation becomes personal knowledge and knowingness. And when enough people do it over thousands of years, it comes down to, yes, these are age-old permanent principles, the cosmos that we live in. A sphere is a sphere is a sphere. A triangle is a triangle. All of these principles, the geometry is from as above, so below. So, again, some keywords here. We'll go through them quickly here. Fractals, self-replication, ratio, rotation, spin, vortex, harmonics, motion, frequency, resonance, very important one there. And the whole thing is based on the concept of oneness and unity, because ultimately, as we experience our own consciousness, we realize that when you just say I am, and then you don't have to put anything behind it, just I am, I exist, and whatever I'm conscious of, it's just endless. You can keep learning and more, you become more conscious. So ultimately all this heads back to unity, because everything falls back as we see the geometry of space. It can fit inside a sphere, because ultimately there's a certain wholeness and completeness about everything that we just can't really comprehend, but we just say, okay, that's the ultimate everything, and we're going to use symbols for that, because these very, very popular symbols have been around for a long time. So let's start. We start with, let's say we have an identity. We know, one thing we know for sure is we exist. There's something exists. So you say, well, there's something. How about we just make a little point in that open space? Something's there. This is why, if you look at ancient cultures, there's one particular thing that they worship, is this, they call the linga here. And the reason is because that pulse, if you look at it from a different angle, a pulse, let's say you have a perfectly serene pool of water, and then some pulse happens. Well, from that pulse, there's all kinds of ripples, and everything kind of starts. So ultimately, we say something starts. And you just symbolize that by a little point. You don't have to, that's it, simplicity. Just, there's a point of identity, and if you look back at symbols throughout all the great teachings, there's a certain sense of what the number one, the completeness, the unity, the totality. It's a concept. Everybody gets it. Now, if you go in a different way, you say, well, okay, so then how do we make a symbol for something that everything that exists, everything, the whole shebang, we don't have to label it or define every detail of it, but we say, well, whatever is all in this container, the universe, the cosmos, that's everything. You symbolize everything. You draw a sphere, because a sphere has an infinite number of points on the outside. And you just say, well, that can represent infinity. And then you go, well, okay, so let's take that a step further. You have the little thing, the one thing that we see, our own little identity, the point of reference, our perception. And then you have this huge, just to represent the infinity. And what if you put that inside there for a minute and symbolize, okay, all that space is what I don't know. There's the universe, the big, huge thing, and then there's this point of perception, and everything in here is unknown. That's vast. So then, okay, well, how do we want to find out what's in that space? So our consciousness as human beings, animals, they just explore. They're always curious, looking and expanding. We're trying to find out knowledge. We're trying to expand and know. Now, you go a step further and you say, okay, it's fine that you have this completeness here and it's sort of a sphere, and it's like, okay, it's contained in this, but how? That's it. It's static. It's just going to be that way. What if that thing, starts to just expand, a vibration happens, and then it starts to separate, and then the next thing you know, you have something like this. Now you have a very, very big symbol. As you see it right here, you can see it in the stars and in the space and galaxies and whatever. A certain kind of it looks like two cells splitting, right? Now you have some action going on here. Now you have a double, you have a two, you have a one over here, then you have a two. Now you have something really incredible, because you're starting to replicate. You're starting to duplicate. From as above, identical below. You have the expansion and the multiplication, and now everything starts happening. So these are really simple concepts that even little kids can understand. It's so simple. You say, okay, we have now we have some action going on. So what if we did this one more thing like this, and we get one more circle, and you have this 3 thing going on here. Now you got some really, really, really huge stuff going on, and you find that this little thing here can fit inside a sphere of the right size, and you have this little triangle in here, and then you have like a whole, now you start having this self-replication, fractals, the as above, so below, the oneness expands similarly. It just replicates itself. That ultimateness, that thing that you can't define, it just starts to replicate, and actually it happens through vibration, harmonics, frequency, and all those harmonics, motion, frequency in a 3-dimensional space. We have to think in terms of energy, and things are moving, and we have to think in terms of more than just a flat space. We hit 3-dimensional. You have 3-dimensional spheres interplanetarian here, and then you have the 3, and then on it goes. And then we'll get into some more complicated things later, but then you start looking at these angles. What are the angles inside here? You can have a square, you have a 90-degree angle, and then you can put a cube inside a sphere and all that stuff. So all that is explained in books like this, and I won't get all into detail, but here's the platonic solids, and there's one more that a famous guy, I'll bring him up later, he found a 7-sided platonic solid, and it was very difficult for him to discover that. But anyway, these are the classic solids. All this goes then from top to bottom, inside the atom, inside the information plane, and everything as above, so below. These same principles apply. That means that, again, getting back to people like Da Vinci, they observe nature and they say, well, I can see the spiral in a tiny little flower, and I can see the same spiral in the stars up in the cosmos, and you can see how profound that really is. So now, just another book here I want to show real briefly here, Sacred Geometry by John Mitchell. And again, this goes into great detail about, it's amazing. So I'm just touching on it, some of the drawings and some of the things that, just to kind of get you started and look in some of these books here and find out, like, wow, artists would be interested in this, and doctors and people who study geometry and architects and all that, all amazing information. So now, go a little further here. We start thinking here, again, this is practical knowledge that we can use ourselves, so we start thinking, okay, well, how am I going to use that? Because if you are an architect, for example, or an artist, or an engineer, the things that we see in nature, that's why some of these ancient cultures, we go back and say, well, how the heck did they build those amazing structures? Because it wasn't like they didn't have an iPhone, but they had a brain, and they had like perception, and they had all this knowledge that was passed down to them about how to do this stuff and how to interpret. And now there's some tools that we get into here, and everybody will recognize them. There we go. See, the famous, it's very, very simple. With this tool and a straight edge and a triangle, there's many different kinds. This is a 30-60, I guess, right? You can get into all kinds of geometry, and again, I can't get into it totally here because I don't have much time, but just to show you, there's, again, ratio and proportion, the phi ratio, the pi ratio, there's so many different things, and it just so happened we get into, when you start getting into numbers, you get into what they call the base 60, or you have a 360 degrees, and that system is still used today, and it has, this particular number has many, many correspondences and what they call factors, because you can go by 2 and then 3 and 4 and then even 5 and then 6, and all these are factors of, so you can conduct math in a spherical way by using even and integer numbers, by using that system. But anyway, that's a very complicated thing. Now again, music, again, is all proportion and vibration and frequency. And again, I put another big word here that we should investigate called sound. Sound can make the shapes and cause cell division and things like that. There's a, that's a whole huge subject. So this is